Japan is currently home to some of the world's top technologies. However, while the Industrial Revolution had begun in England in the mid-1700s, modern industrialization in Japan only began in the late 1800s. There were huge cultural differences. Screws, which are essential to modern industry, were almost unheard of at the time in East Asia, including Japan. Even so, Japan acquired these technologies in just a few decades and built industrial capabilities on a par with Europe and the United States. Later, after being devastated in World War II, Japan's industries recovered with astounding speed, making Japan a nation of science and technology. Japan's technologies and industries were supported by higher education in engineering, which produced outstanding industrial human resources. Here, we will examine the secrets behind this success. In the mid-1800s, Western countries, which had been colonizing Southeast Asia, began extending their reach into East Asia. Japan was astounded by the advanced industrial technologies of countries coming to Japan seeking trade. Although still a feudal society at the time, Japan's literacy rate was more than 80%. It also possessed advanced mathematical knowledge and original technologies. However, industry was still focused on household-based handicrafts. Steam engines and other advanced Western technologies came as a shock. Facing down the threat posed by advanced Western countries eventually triggered the modernization of Japan's political structure itself. The long-standing feudal era, led by the samurai, came to an end with the Meiji Restoration and its modern centralized government. The building of a new nation thus began. However, such internal chaos of that time exhausted Japan's economy. The new government therefore promoted industry as a national policy. It attempted to transfer modern Western industrial technologies to Japan to develop and protect. As part of these efforts, the government emphasized realizing the educating of engineers by Japanese instructors.
日本では幕末から明治初めにかけて若い人たちを西洋に派遣し科学技術を学ぶ機会を作りました。また西洋から技術者や大学教員などを数多く呼び寄せ短期間のうちに科学技術や文明の進歩を成し遂げました。当時明治新政府は欧米からの侵略への危機感を持っていたと思われ短期間で殖産工業の推進と近代工業化を進めることが極めて重要と考えていたと思います。
The government studied which technologies and industries to adopt and from where. It dispatched delegations and students to advanced countries to learn them. They became the people who formed the core of the newly established Ministry of Industry, a central government ministry for promoting industry. Japan invited and hired from advanced countries foreign experts in various fields, including mining, railways, communications, and machinery production. Massive funds were invested to build infrastructure and develop industry. As a result of these efforts, in less than 10 years from the launch of the Meiji government, Japan achieved astounding advances in railways, communications, mining, and other fields. Japan focused its efforts on promoting industry as well as on training Japanese engineers and instructors, who would be essential to the continued operation of these technologies. The Ministry of Industry immediately established technical education institutions to foster human resources in modern industrial technologies. Japan's first true technical education institution began as the School of Engineering in 1873, changing its name to the Imperial College of Engineering 4 years later. The goal was to foster advanced engineers in a wide range of fields, including civil engineering, machinery, architecture, communications, chemistry, metallurgy, mining, and later shipbuilding. Here again, foreign experts were hired for substantial compensations to come and teach. Japan undertook human resources training, knowing that its very survival depended on it.
明治新政府では当初、公務省の予算の7割近くがお雇い外国人の人件費に充てられていました。我が国の技術者は短期間で彼らから科学技術を習得する必要があったと思います。これが近代工学教育の始まりと見ることもできます。当時日本にはそれらの事業を支えるための資金を国産の産業によりかろうじて生み出すことができたと思われます。銅や銀など当時の欧米が必要としていた鉱産物や生糸などが外国に支払う資金を生み出したと思います。西洋技術を導入するために多額の資金を若い人材の育成に使用し、日本の未来を彼らにかけたと言っても言い過ぎではないと思います。
In early Meiji, institutions other than the Imperial College of Engineering were also created to train human resources for Japan's industrialization. Policies related to training were overseen by the Ministry of Education. The Department of Science was established in 1877 at Tokyo University, Japan's first modern university. Meanwhile, the Tokyo Vocational School was established in 1881 to provide practical engineering education. Tokyo University placed greater weight on mathematics and basic science, and made theory the focus of its learning. The Tokyo Vocational School covered a wide range of fields, including industrial arts in general, fostering frontline leaders and instructors. Compared to these two schools, which even now maintain similar philosophies, the Imperial College of Engineering was unique in that, true to its times, it strived to rapidly introduce new technologies. Henry Dyer came to Japan as the first principal of the Imperial College of Engineering. The philosophy he put forward can be said to be the most unique feature of this college. That philosophy was the judicious combination of theory and practice. Based on the educational principle of emphasis on the front lines, the college offered original technical education that combined frontline practice, suited to the Japanese environment, with systematic theoretical learning. The latest Western technologies brought in by these foreign experts were modified to suit conditions in Japan before they were passed on to the students of the Imperial College of Engineering. In this way, the college produced human resources with outstanding ideas and skills, who would go on to lead the modern industrialization of Japan. The number of foreign experts that were hired began to decline as more students graduated from the college. 11, or about half, of the first graduating class were dispatched to study in England. This was in part to receive training to become instructors at their alma mater. Efforts were directed at achieving technical education taught by Japanese instructors. This goal was achieved with remarkable speed. Then, in 1886, the Imperial College merged with the Ministry of Education's Tokyo University, and closed its doors after a little more than 10 years. During that time, the Imperial College produced several notable graduates, including outstanding Japanese engineers who led Japan's cultural enlightenment during the Meiji era. Those who became instructors fostered the next generation of engineers, disseminating modern industrial technologies throughout Japan. The Imperial College of Engineering laid the foundation for independent technical education in Japan, enabling engineering education by the Japanese in Japanese. The remarkable development of modern industry in Japan in early Meiji was made possible with the support of its launch by this unique school. The Imperial College's mission came to a close when it merged with the Imperial University. This was followed by the rapid development of Japan's modern industry. While the initial policy was to promote government-managed industry, Japan adopted an entirely new direction: to foster industry and capitalism in the private sector. This further increased the demand for engineers, not only from government, but also the private sector. The Imperial University's Department of Engineering served as a model for Japan's modern universities, with a full staff of faculty for research and education. It played a central role in engineering education, expanding to include 7 schools throughout Japan. The Tokyo Vocational School also strengthened its role. As if following state-run educational institutions, engineering education gradually developed at private schools, continuing to meet the growing social demand for engineers. Then, about 70 years from the start of the Meiji government, the dark cloud of war once again fell on industry, which had continued to grow. In 1945, Japan was defeated in World War II. Many major Japanese cities had been destroyed. The war also devastated Japanese mining and industries. Production capacity fell to just 1/5 of pre-war levels. Rapid recovery was critical for the sake of citizens' livelihoods as well. The war damaged more than the materials and facilities required by industry. Many of the human resources possessing the skills that supported industry were also lost in the war. The key to recovery was to augment engineers. As economic activities gradually returned to normal 10 years after the end of the war, there were increasing calls from the private sector to increase the industrial labor force. The government once again took the lead, starting the training of industrial human resources as an economic policy. Schools of science and engineering at both national and private universities increased their student quotas. Private universities received subsidies when establishing new schools of science or engineering. The conditions to be met were also gradually relaxed. With greater demand for higher education among a rapidly growing population, efforts were made to enhance engineering education institutions. Through such efforts, which began in the late 1950s, the number of engineering students increased 5-fold in 20 years. Their employment rate was close to 100%. This gave rise to a positive cycle that promoted the development of Japanese society. Financial support for universities helped foster scientists and engineers and provided industry with a stable supply of engineers. Their innovations expanded production capacity and increased the competitiveness of Japanese industry. as demand for exports increased, Japan's rapid economic growth got on track. Japan rose from post-war devastation to become a leading science and technology nation in a short span of time. Even as rapid economic growth enabled many citizens to enjoy improved lifestyles, damage to people's health and the environment increased due to pollution. Society as a whole came to recognize that the promotion of industry must come in tandem with environmental conservation.
戦後の工学教育は大学が増え学生定員が増えただけではなく、教育の質の向上にも力を入れていました。欧米の工学教育は座学中心が一般的ですが、日本では卒論研究や修論研究など学生の時から自分の研究テーマに基づき考える力を養うことにも力を入れてきました。またものづくりのような実践的な教育も機械工学分野などでは重視されてきました。日本は地下資源が乏しいため、これに対応するにはかなりの工夫が必要だったと思います。一方、明治時代の鉱山開発や戦後の急激な工業化により、さまざまな環境破壊も進みました。各大学では環境問題を解決するための工学教育にも大きな努力が払われました。現在の新興国や途上国でも環境問題は大きな課題ですが、工学教育を通して克服し、さらなる発展につなげることを期待します。これは SDGs にもつながるものと思います。
Japan overcame difficult circumstances to achieve modern industrialization, rising to become a leading nation in science and technology, despite various challenges. Even today, the driving force is an abundant and skilled industrial labor force, supported by engineering education. We can see a common element in the two foundational periods of Japan's development. During the dawn of modern industrialization, Japan adopted a policy of promoting industry to resolve its disparity with the West. The government used its funds to hire foreign experts. Under their guidance, Japanese instructors were nurtured to establish a system of higher education in engineering. Next, after World War II, the government adopted measures to augment the science and engineering labor force. The wealth of the industrial world generated by exports was applied to those measures. In addition, the increasing popularity of research-centered education led to the broad development of higher education in engineering, which grew in both quality and quantity. Goals were set based on such factors as social conditions. Government policies and funds were combined to promote engineering education. This approach ensured the steady development of an advanced industrial labor force in Japan.
日本の科学技術分野の発展は、海外から学んだことを自国に取り入れて、さらに工夫を重ねて発展させたことの結果だと思います。途上国も同様のアプローチで、人材育成、産学連携を通じた科学技術の活用を発展につなげてほしいと思います。
For many years, the Japan International Cooperation Agency, JICA, has applied Japan's own past experience, as described here, to support the development of human resources around the world. Even now, JICA continues to support higher education in engineering in various countries and regions, including Africa and Asia. One example can be found in Eastern Africa in Kenya. The Africa Eye Japan project is focused on the Jomo Kenyatta University of Agriculture and Technology, outside the capital city of Nairobi.
アフリカ連合が2013年に打ち出した アジェンダ2063というアフリカ独自の人材育成を目標としたプログラムに沿って、アフリカ連合の主導のもとに作られた大学院大学を支援しようというプロジェクトです。
The key is to set up key infrastructural development, improve on the manufacturing capabilities of these countries, and develop human capacity to support this development. These are the aspirations and goals of many African countries so that they may continue with the journey of self-sustaining and attainment of the medium and short-term goals.
The project began in 2012. Jomo Kenyatta University of Agriculture and Technology, JICA-Net, which Japan has supported for 40 years, was chosen as the project base.
大学での工学教育というのはやはり実技というよりは理論中心の教育が行われてきました。で、ジョモケニアッタ農工大学では日本の長い援助があることによって実技を重視した工学教育というものが独特な形で行われていました。
With JICA-Net as the host university, the Pan-African University Institute for Basic Sciences, Technology and Innovation, POSTI, was established to accept students from other African countries. It supports their education and research activities. In addition to dispatching faculty members, Japan also provides a wide assortment of other support for human resources development in the field of science and technology. To upgrade research environments, it was necessary to accommodate the conditions in African countries, which differ from Japan.
1年生の時から工学部に所属すると、さまざまな工学に必要な技術というものを集中的に習得するということで、ワークショップを充実させることによってそのような実技を重視した教育というものができるようになってきます。その中でもケニアで入手が可能な資材を用いた加工技術というものを習得してもらうということで、外部から直接持ち込んだような機械ではなくて手でさまざまなものを作るというアフリカ型のものづくりを実践させるということに重点を置いてきています。
This is Dr. James Mutua, who is currently serving as a lecturer at JICA-Net. He obtained his PhD through this project.
So we can say this is a success from me being a trainee and now becoming a trainer. It is really bearing fruits because there is that kind of you train to become a trainer, and actually this happens on the ground. And for sure, it is a success, as I may judge on personal account.
POSTI welcomes about 100 students each year from various African countries. Coming from as many as 44 countries, they are gaining the skills needed to support innovations in science and technology in many African nations. This project is gradually bearing fruit. Rather than simply providing human resources training, it maintains a view toward the next stage as well.
We are nurturing talents to do with self-commitment and ability to become an individual or own researcher, such that once these students graduate, they are able to become thematic leaders in their area of training. And therefore, there is a lot of knowledge transfer which creates a solid individual who becomes a pillar in the area they are being trained in when they return to their countries.
アフリカでは経済発展がかなり速い速度で進んでいます。そういう一方で、アフリカ独自の技術開発というものがなかなか行われていないということがあります。これは後進国のために様々な技術が外部より持ち込まれていることによります。ところがアフリカ独自の知恵であるとか知識、技術というものが少しずつ育ってきています。このようなアフリカの技術や知識というものを使った産業というものを創設し、さらに社会的に安定した経済発展が遂げるような工業技術というものを進行していきたいというふうに考えています。
In Asia too, JICA conducts activities based on the understanding that globalization is needed not only in the economy, but also in education. The name of this project is AUN JICA-Net. It involves a network of 40 top universities in the field of engineering in Japan and ASEAN countries. The goal of this ambitious project is to improve the skills of the faculty members of member institutions. It promotes joint research and academic exchanges that leverage this network to resolve regional issues and establish collaborations with industry. One unique feature of the project is that it assumes participating students and faculty members will remain at member universities and continue their activities as faculty members or researchers. This project began 20 years ago, mainly as a scholarship program to encourage foreign students to study abroad and obtain degrees. It has evolved substantially since then.
シードネットの場合にはですね、ASEAN10 カ国すべてが対象になっておりますし、それもそれぞれの国の発展度合いに応じて違った役割を持っているっていう点で非常に特徴的な取り組みだと思います。なかなかマルチラテラルな取り組みっていうのはそれぞれの国の利害が必ずしも一致しないということでなかなか難しい面あると思うんですけれども、このシードネットの取り組みというのは、それぞれの参加者がそれぞれの立場で非常に有益な成果を得たのではないかと感じております。
The young faculty members and students strive to obtain degrees at member institutions in ASEAN countries. They also have opportunities to conduct research activities while staying in Japan. In addition to such advanced human resource development through scholarship programs, JICA-Net also encourages joint research with Japanese universities and other member universities. Professor Tan Rizmi teaches bioengineering at the Institute of Technology of Cambodia and is also Deputy Director of the Research and Innovation Center. Many center faculty members obtain their degrees through the JICA-Net program.
When I was studying in Japan, my professor told me that the time flies so fast, so no paperwork, no work will be done. So it means that we need to publish paper regularly when we do research. For me, even now, I also still publish academic paper through local and international journal and also conferences.
The program has created a positive cycle that fosters many outstanding individuals who then form a network to further expand the scope of joint research. In this way, JICA-Net brings about one innovation after another to resolve common issues and contribute to industrial technology development.
I focus on pathogen and phytoplankton. So in this project, we investigate the pathogen in rainy and also in dry season. And also I focus on multi-drug resistant bacteria. So according to our result, we found also multi-drug resistant bacteria, especially in sewage water that is discharged into Tonle Sap River. So from this result, it also we can provide like a recommendation to stakeholder. So it means that the sewage should not be discharged directly to the Tonle Sap River. The sewage water should be treated.
さまざまな可能性がある、それだけの、数の卒業生もいるっていうところがですね、シードネットの、成果、今後もですね、JICA のプロジェクトとしては終了した後もですね、さらに大学間のネットワークつながりとして発展をしていくことが期待される。今度はこのシードネットをですね、本当の大学間の協力のネットワーク、対等なネットワークとしてですね、発展していくことを期待してますし、日本の大学もその意味ではですね、ASEAN の、各大学と対等な付き合いという形で今後もコミットしていけるのが一番いいのではないかと感じています。
Japan has abundant and advanced industrial human resources and has enjoyed the benefits of outstanding industrial technologies. Changes continue to be required, however, in higher education in engineering.
現在の新興国や途上国でも短期間に自国の教育システムを確立し、各国の大学で産業に必要な優れた人材を育成し、経済的、政治的に他国に依存しない国づくりを実現することが可能だと思います。私たち日本は皆さんの国との友好関係を維持し、信頼関係をより強固にしながら豊かで平和な国づくりを共に目指したいと思うのです。今世界で何が必要かというと、まず何よりも若い人材です。皆さんの国にいる若い人材が、これからの地球を、救うかもしれないし、日本とそして皆さんの国と一緒に共同で何か作り上げていくというのが今必要なんですよ。ぜひ一緒にこれからの地球の未来を作っていこうじゃありませんか。
For countries striving to develop in the future, and for Japan as well, understanding and respecting each other's cultural differences, and building relationships that encourage cooperation and collaboration, that is the path toward creating a richer future.